Okay, so this is section 3.5 on non-homogeneous equations, and we're going to look at the method of undetermined coefficients for solving these types of equations. Okay, so we're considering an equation of this form. Okay, right now I'm making the left-hand side so that it has constant coefficients. A, B, and C are constants. Okay, but notice now that on the right-hand side we're no longer setting things equal to 0. This is set equal to g of t, okay, some function of t. All right, and so in this case, what do we do? Okay, well, this method of undetermined coefficients is basically a way of just using an educated guess. Okay, all right, so let's consider this example: y double prime plus 3y prime plus 3y, I'm sorry, plus 2y equals 10e to the 3t. Okay, as I said, this method is based on using an educated guess. Okay, but one thing about this method is that it's not really foolproof. Okay, so keep that in mind. We'll learn other methods for solving non-homogeneous equations later that are considered more foolproof. For this problem, though, notice that this right-hand side it's an exponential function. Okay, so if we were to think of something to guess as a solution to this problem, what would we think of? Well, if the right-hand side is an exponential function and we are ultimately going to have a guess that we differentiate once and then twice and then plug into the left-hand side, in order for the left-hand side to match the right-hand side, we need to use an exponential. Okay? And not only that, but it needs to be like this exponential, this e to the 3t. Okay, so a reasonable guess is something like this. So, and this is, what we're going to do is we're going to find what's called a particular solution. And so this will involve a guess. I'm going to use a subscript p for particular. We're going to guess the solution of the form a e to the 3t. Okay? And so the a is an undetermined coefficient. Okay, we have to try to determine a by plugging this in to the differential equation and seeing if we can come up, if there's some reasonable value of a, okay, some exact value of a that satisfies the differential equation. So if I guess this, if I plug it in, well, I first have to find derivatives. So y prime, in this case, is 3a e to the 3t. And then if I find the second derivative, multiply by 3 again, I get 9a e to the 3c. Okay? So I have y prime, y double prime for my guess. I substitute into the differential equation. So we get, so y double prime is 9a e to the 3t plus 3 times yp prime, that's 3a e to the 3t, and then plus 2 times y, and y was a e to the 3t. This must all equal 10 e to the 3t. Okay? And we can combine the stuff on the left-hand side. So we have 9a e to the 3t, another 9a e to the 3t, plus a 2a e to the 3t. Combining those, we get 20a e to the 3t must equal 10 e to the 3t. Okay? And notice that for this problem, we can actually solve for a. Okay? And of course, a is going to be 1/2. So a equals 1/2, and we have that our particular solution is equal to 1/2 e to the 3t. And I just want to make sure that, yes, so that is the particular solution. But this isn't the whole solution, okay? This is really just part of a solution to this non-homogeneous problem, okay? And now I'm going to discuss the other part of the solution, which is what's called the homogeneous solution. And so since the other part of the solution is called the homogeneous solution. You should think about how we find it. We find it by finding a solution to the homogeneous problem. Okay, the homogeneous problem is setting the right-hand side equal to 0. Okay, so I'll erase the board. I mean, we can remember that our particular solution is 1/2 e to the 3t. And I'll keep this here, 10 e to the 3t. And so now we find a homogeneous solution. And we don't really have to write down that equation. I mean, we know that the homogeneous equation would be right-hand side equal to 0. Okay, so imagine that the right-hand side is now equal to 0, and we want to find the homogeneous solution. What should we write down? Characteristic equation. So the characteristic equation is r squared plus 3r plus 2 set equal to 0. Okay? And this has nice roots, r, so let's say r plus 1 times r plus 2, I believe. Is that equal to 0? And so we find that we have two roots. r1 equals minus 1, and r2 equals minus 2. Okay? So these are distinct real roots, and we can find that homogeneous solution, and I'll label it y sub h, as a linear combination of these exponentials. c1 e to the minus t plus c2 e to the minus 2t. Okay? So this is the homogeneous solution, okay, where, like I said, we've set the right-hand side equal to 0. And the general solution is now a sum of the two. So the general solution is y of t equals y homogeneous plus y particular. Okay? And so in this case, y of t equals c1 e to the minus t plus c2 e to the minus 2t. And if I bring back that particular solution that I raised, it was, I believe, plus 1/2 e to the 3t. Okay? Now, if we had initial conditions, C1, or if we had initial conditions for this problem, we could solve the initial value problem. We could solve for the C1 and C2. Okay. But one thing I want to point out is that sometimes our guess doesn't work so well. Okay, and either in a future video or in future lectures, we'll see when that guess doesn't work out. Okay, but this time, notice the guess did work.